Welcome everyone. I'm Nicolas Loof. I'm an informatics solution leader at BDB Informatic, aka FlowJo. I put my email address on the slide. Don't hesitate to reach out to me in the future if you have any question. Also, put the FlowJo support team, flowjo@bd.com. If you have any question about the software or issue with the software, is the right email to contact. So for this webinar today, we're going to talk about quality control in cytometric analysis using FlowJo 11. So why do we need control? So when you run your sample on the instrument, there's a lot of technical anomaly that can happen. You can have a surge in the flow rate. You can have a fluctuation in the signal. You can have a fluorescence event outside the dynamic range. And all those events gonna create anomaly on your sample. So false event, they are not true cells. And those anomalies can lead to false discovery. So here's an example of false discovery due to a technical anomaly. Here on before the QC, you can see that we have a 3 population of CD3. So it seems like a negative CD3 population, a dim CD3 population, and a bright CD3 population. But when we look at a time gate, so a time versus one parameter, we can see that the beginning of the run for that sample was not stable. So we probably had a technical anomaly from the instrument, which caused to create this negative population, which was not true. So the true negative population is the one we thought could be dim in the before QC. So when you run manual gating and you know the biology, you can tell which population is correct or not, and maybe you can figure out if there's any anomaly and go back to the QC if you haven't done it before. But now that the field is going more and more to the high parameter analysis using dimensionality reduction and clustering, you may miss this issue. Here's an example from a paper in cytometry, part A, and you see that at the beginning of the run here, it creates a specific cluster when the rest of the run create every other cluster. So this red cluster there were measured during the startup phase of the acquisition, and it was an unstable period of the run, which resulted in creating those clusters. And you may spend time and a lot of money to try to characterize those clusters when in reality they're just anomaly or artifact. So we want to make sure that we remove all those technical anomaly. And there's 2 ways to remove those technical anomaly, either a manual way or an automatic way using algorithm. So the manual way is to use a time gate. That's what we've been using for the past 20 years. So you look at a time parameter versus another parameter, and you make sure that your run is stable. If the part of the run is not stable, you're just gonna gate around it to remove that unstable part of the run. We used to do it on for scatter, a scatter parameter versus a time gate, and just select the stable part of the run. But in reality, you should check at least every laser that you have on your instrument, but preferably every parameter that you're using to run the instrument. And to be honest, if you're running a 20 color experiment, you're not gonna do 20 time gate to make sure you remove any technical anomaly that can happen during the run. So to have a better result of better QC, it's better to use algorithm to do the QC. They're gonna save you time and they're gonna do a better job that doing this time gate that we used to do. So there's many algorithm available to remove those anomaly. So we have FlowAI, Peacock, FlowClean, FlowCut. Those algorithms are available in FlowJo v10 as a plugin. But in FlowJo 11, we integrated the QC in FlowJo 11. So you can use the FlowJo 11 QC as well. And because this talk is focusing on FlowJo 11, I'm just going to talk about the FlowJo 11 QC. So how does that algorithm work? So the FlowJo 11 QC is going to inspect your FCS file. It's going to remove those anomalous events, and it's going to return a high quality event. And at the end, it's just going to give you a report in your discovery panel where it's going to tell you which event has been removed and why. And at the end, in your population, it's going to give you the good event and bad event, and you're just going to keep doing your analysis on the good events. So what algorithm or how it works? So we base that uh, FlowJo 11 QC on FlowAI. So FlowAI has been published, so you can read the paper. It's the paper from Germany, Monaco, from the Singapore Immunology Network. And FlowAI is looking at the three main reasons for technical anomaly, which is the flow rate, the signal acquisition, and the dynamic range. So the way it works is just going to create really small time being of your sample, and it's just going to make sure that between each time being, you have about the same number of events, meaning your flow rate was stable. If you see a burst of number of events or a decrease of number of event, it may be just you got a big train of cells that went through the flow cell at one point, or you got a clog or an air bubble, that's why your flow rate dropped. So we want to remove those small time beats. It's going to look at the signal acquisition, which is your MFI. So your MFI should be within 2 times the standard deviation. So if it's outside that range, it's just going to remove that part of the sample. And it's going to look at your dynamic range. So your instrument has a window where it works the best. You want to be above the electronic noise and within the linear range of your instrument. If you're outside that range, the measurement you're going to get will not be accurate. So we're going to remove every event that's outside that range. So why did we use a FlowAI-like algorithm for the FlowJo 11 QZ is because he used raw data when the other one used compensated data. And we thought it was really the first step to do when you do an analysis is to do the QC. So that's why we decided to go to a FlowAI-like QC. The only thing that we changed from FlowAI on this FlowJo 11 QC is the flow rate check. So instead of using the mean and the standard deviation of mean for the variation, we look at the MAD. So MAD measure how the spread out of a set of number is. So if you have a small MAD, that means the numbers are close together, so you have low variability. When if you have a large MAD, that means the number are more spread out and more you have high variability. And the reason we go to MAD instead of the SD mean is because it's less sensitive to extreme value than your standard deviation. All right, so let's look at the settings of the QC in FlowJo 11. So first, you're gonna select the parameter you want to include into your QC. So most likely all of them, maybe except the scatters. You can remove the scatters if you want, but at least all your fluorescent. And after you can select if you want the signal stability check, the flow rate check, and the dynamic range just by turning on and off those options. So first option is your signal stability, so your MFI, as we already talked about. So you can change the change point maximum, and you can change the change point penalty. So the change point is basically the number of places where the trend can change. So going up, down, so it should be consistent, or going up slightly or down slightly or stable. If you change too many times, we're gonna flag at that. So if you want to be more strict, you just need to lower those values, the change point or the penalty. Then for your flow rate, as I said, we use the MAD, so the mean absolute deviation number. So the lower the value, the more strict. As I say, that means the closer the number together, so you have less variability. If you put a large MAD number, that means you have more spread out or high variability. And the dynamic range is to select whether the dynamic range should be performed on the upper or lower limit or both there. So if you use QC and FlowAI in particular in FlowJo 10, you know that it was taking about 15 to 20 seconds per sample if you had about 500,000 to 1,000,000 cells per sample. In the QC in version 11, we really improved by a lot the performance. So now you see in this example, and I just recorded my screen, you have about 1,000,000 cells, between 500,000 to 1,000,000 cells per sample, and we have 20 sample. And you will see when I press run, I just recorded my screen, didn't speed it up. That's the actual time. It will take 15 seconds to run all the QC on all sample. So a huge improvement there. I see a question in the chat. What? No. Okay. And there you go. The QC is been run in FlowJo 11. So you have your report in the middle. Okay, for this particular sample, you can go from sample to sample either by clicking on the sample here in the sample section, or you can use the arrow left and right to go from sample to sample as well. So we can see what's been removed, everything that's yellow is what's been removed, everything that's is blue is been kept, and we see that it removed at the beginning of the run because of the flow rate being unstable, and also because of the signal stability not to be within the 2 times standard deviation as well. At the end of the run, it's going to give us a check mark on our experimental data group, telling us that the QC has been run on all the sample, and it's going to give us the good event and the bad event, which basically you keep doing your analysis on the good event. So if you want to check also the bad event to see what's been exactly removed, and maybe you want to do your analysis on the bad event to make sure that it's really something that was bad, you can as well do it. If you want to adjust the number, you can always readjust the number, click apply, it will rerun the QC, overwrite the past QC with the new setting that you just put. All right, so let's look now of a good run. So the one I just told you. So we have the beginning of the run that's been removed here. The rest of the run was kept. See that the flow rate changed there when drop up, really unstable. So either the pressure, the surge depending of the instrument, I don't remember what instrument it was on, but was not stable until the flow rate was stable. And this resulted in your signal as acquisition, so MFI not be stable, so we just select the stable part of the run. But now let's look at a problematic run. You see on this run, it removed as well the beginning of the run of a sample and it kept everything else. And if we look, we see that the flow rate was about 1,000 at the beginning, and after a few seconds, or let's say 500 seconds, it went to 1,500 events per second. My MFI was stable, everything was stable, and it removed, because of that, a bunch of events. But really, what happened here was a change of speed on the instrument. The user, if they were using, I don't know, a symphony or something like that, they put from low to medium, a medium to high, or if they're using maybe a canto, they just change the speed directly in the software, or they just increase the number on queries from 1 to 10, etc. for the speed. So really here, if just the user wanted to run faster for whatever reason, maybe there was a user behind him that was just waiting to jump on the computer, on the instrument, and they were at the end of the time and I wanted to make sure they run the full sample, or maybe he thought 1,000 event was too late. But anyway, they physically changed the speed, so it's normal that the flow rate increase. Well, if that's the case for you and you have a sample like that, you can just turn off the flow rate check to make sure that it keep everything from your sample. And best practice, if you know that you're gonna run the QC, just make sure that you change the speed between sample and not within the sample. All right, so we remove any technical anomaly coming from the instrument. So now we want to remove any event that we're not interested in. So we want to remove the doublet, the debris, and the dead cells. So to remove the doublet, we're gonna use the property of the electrical pulse from the cells crossing the laser. So when your cells cross the laser, you're gonna have emission of light. This light is gonna be transformed into an electrical pulse. So here's the electrical pulse. So if one cell cross the laser, you're in baseline, the cells start crossing the laser, so you have emission of lights or a creation of electrical pulse. When the cells is inside the laser, you have the maximum emission of light or maximum electrical pulse. And after when the cells leave the laser, you go back to baseline. And this electrical pulse can be characterized by three values: height of the pulse, the width of the pulse, and the area of the pulse. And that's what you see when you see forward scalar A, forward scalar H, forward scalar W. So A, H, and W in every parameter on your instrument correspond of the height, the width, and the area of your pulse. Now, if you have two cells crossing the laser at the same time, being a doublet or multiplet. So when the first cells cross the laser, you're gonna have the pulse that's gonna increase, go to the maximum peak, and after when you're going, the first cell's going out of the laser, the next cell's coming back in, so you're going back up, and when the two cells going outside the laser, you go back to baseline. So you were not able to go back to baseline between the first cells and the second cells, and that's how we detect the doublet, because now your pulse value, your height's still going to be the same because they're the same size of cells, but the width is going to be way longer because now you have two cells that cross the laser, and because of that, your area is going to be way better. So that's why we plot area versus height or height versus width. So if you plot height versus width, height can increase, but the width cannot. If you plot area versus height, you're gonna select the diagonal. Everything that's not in the diagonal that have more area than height, that's gonna be a doublet. All right, so now let's remove the debris. So that's just your forward scalar, side scalar gate. Just make sure that you put your cleanup gate around your population of interest. So if you're on a cell line, just put it around your denser population. That's usually where your cell population is. If you have a heterogeneous population like whole blood in this example, you're just gonna select your lymphocyte, monocyte, granulocyte base on your experiment. And of course, the last one, you want to remove dead cells. So live dead marker is crucial in any flow cytometry experiment. So make sure that you have one in every experiment you're doing. And this allow you to remove your dead cell, because dead cell is going to catch almost every antibody. So you may think it's double positive when in reality it was just a dead cell that caught, I don't know, CD3 and CD19 double positive. Here's an example. So here's the result of STAT5 on the CD4 cells, and you see that without the live dead removal, we have about 40% of STAT5 cells positive, and with the live dead removal, and we have 61%. So really, the lack of variability die in this case underestimate the STAT5 CD4 T cells frequency. So to summarize, that talk, and the quality control of your data can help prevent false discovery and is important to first step in any flow cytometry experiment and analysis. Sample quality can be assessed and post-acquisition anomaly removed in the FlowJo software. And multiple debris and dead cell should be excluded from your data before continuing with your downstream analysis. All right, so now let's jump on the software and let's do this live demo. I see a question in the chat before I jump there. Around when did algorithm-based QC approach like this start to become widely used? I was actually working on the flow cytometric in 2000. I don't remember. I graduated them at the time. Flow Clean was the first QC algorithm published. And if I remember correctly, it was in 2016. Flow AI was really short after, a few months after, maybe less than, I think less than a year after that. And the last one published was Peacock and Floca that were both published, I believe, at the same times or around the same times in 2022. So you are correct. In 2010, there was none. All right, so let's jump the software, share screen there. We're gonna open FlowJo 11. So first thing I need to open is my BD Access portal. Make sure I'm logged on. There you go. Put my credential. Okay, make sure your green icon there, but your icon here is green, meaning that I have access internet and I have no proxy or anything that's blocking the check of my license. Sign in. There you go, I'm signed in. So now I can open FlowJo 11.1. Okay, so this FlowJo 11.1. I'm gonna open a new workbench. I have as a theme, I have Tangerine. You can change that to whatever you like. I like this kind of dark color with this orange contrast, but if you want to have in the light mode, dark mode, or maybe Veronica's or whatever you like, you can pick. I like the Tangerine one personally. I'm just gonna remove the camera. Okay, so let's bring the data in. So I'm just gonna bring this multi-disease study. So we have the compensation control and the fully stand for COVID, flu, FE, and RSV. So I'm just gonna select that and click and drag those folder. So it's gonna create automatically my group. Okay, so I created a group for my composition control with all my composition, and on my experimental data here, I can see my four. I don't need the full sense, so COVID, flu, healthy, and RSV. Okay, so I'm not gonna go through all the functionality of FlowJo 11. We're just gonna go directly to the QC, so which is this icon there, the second one on the bar, on the left side bar. Okay. We're gonna select the parameter right here. So maybe remove the scatter and just keep all the fluorescence parameter. Right. So do I want signal stability? Yes. If I didn't want, I can uncheck it. Do I want flow rate? Yes. Do I want dynamic range? Yes. Okay. Default are pretty robust, so you barely don't have to change anything. If you want, you can adjust the penalty. For example, if you want to be a little bit more strict, so you can maybe 200 if you want to be really strict, or leave it to 500 if you're happy with it. And here, I'm just going to click on apply. So you see I have 20 sample between 500,000 to 1,000,000, like I did in the live demo. It should take about 15 seconds to run the QC on all those samples. And there you go. QC has been run. Okay, so now we can check from sample to sample. So here I see B515 versus time. And I see my flow rate, my signal stability for every parameter. And you can see that you remove the beginning of the run because my flow rate was not stable, and you remove this end of the run because we drop under the threshold there. So if I'd want that, I can change my MAD number, etc., to or my change point to make sure I include those events. But if I look at the rest, same thing. A little bit of an issue at the beginning of the run here. There, a drop in the flow rate, a burst at the end here in my signal stabilities. That's why I removed the end of the run, etc., etc. Okay. Pretty happy with that run. It's fine. As I say, if you wanted to change, it can be more strict. For example, click apply, and it's going to rerun the QC on it with those change of parameter. Okay. So now that you're happy with the QC, now you can go in your good event, in your graph tab. So you have your primary graph right there on top. You have your discovery panel, and with your graph gallery in this case at the bottom, I can select whatever sample I want to see as a primary graph. If I want to concatenate all my samples together, I can use the virtual concatenation to see all of them together now here. I can decide what type of plot I want to display. So pseudocolor, histogram, dot plot, heat map, statistic, contour. I'm just going to leave it on pseudocolor. You can change the resolutions, basically the size of your dot. So if I do 128, it's going to be way bigger dot. If I do 1024, it's going to be a way smaller dot. You can change the background, do some smoothing, but can even change the color of my pseudo color. So maybe I can do plasma there. And now I can select my population of interest. So I'm going to select my cells. Cell of interest. Double click to close it. Label it, create. And now it's a subpopulation of my good event. Can double click to select it. Now I can go to my forward scatter A versus forward scatter H and select the diagonal. Just gonna put it back to regular. Select my diagonal to remove any doublet, singlet, forward scatter. And you need to also do your doublet discrimination now on the size scatter. So we do size scatter A versus size scatter H. And now we select the diagonal as well here. And the reason we have to do forward scatter and side scatter, A versus H, is because if the cells are perfectly on top of each other, side scatter will not see that as a doublet, but forward scatter will. And if the cells are perfectly aligned with the laser, the second cells will be in the shadow of the first one, so forward scatter will not see that as a doublet, but side scatter will see it. So if you want to make sure you remove 100% of your doublet, you need to do both forward scatter and side scatter. Okay. And now I can look for my live dead marker. Where's my live dead marker here? Then there you go. And can do an histogram instead of pseudo color if I want, and select only the live. Okay. And I did that on my experimental data. That means that getting strategy is the same for every different group or every different sample, and I can go in each group, and on my live cells, I can start doing my analysis on specific group, and you will see the color of each gate for each different. So if, for example, here, if I do CD4 versus CD8 and select my CD4 on my COVID group, D8, see that my group, my gate here is purple, the same color as my COVID group, telling me that this gate is specific for the sample included in my COVID group. And if I go on my flu, I will not have that CD8 gate. And because I run the QC, there you see the check mark is there on my experimental data, and I had my good event, bad event, as I mentioned. Okay. With that, that's the end of this presentation. I'm happy to take any question that you may have regarding QC in FlowJo. So put it in the chat or put it in the Q&A so I can answer. Yeah, so the webinar has been recorded and it's going to be available on our website. So let me share that, share my screen again really quick so I can show you where. So if you go back on the FlowJo.com website where you register, you go in Learn Webinar. So you see the upcoming webinar. So you see the one we're doing today. And if you go down, you see all the previously recorded webinars. So you're going to see that webinar being posted there in the next few days. All right, so recording webinar done. Is there a particular order to exclude the doublet? Should I do forward scatter first, then side scatter, or the other way around? No, there's no order. You can do it either way. Is FlowJo 11 QC algorithm suitable for all cell type? That setup was developed for as a fan flow tool optimized for T cells. This algorithm influenced by very autofluorescent cells such as macrophage, suitable for research on such cells. No, there's no limitation. Every cell type, every particle, you can even use beads or whatever. So basically, we just look at consistency over time. That's the only thing we look at. So your cells are coming randomly through your instrument. So if we take a small time bin of your sample, it should be the same at the beginning of the run. Then at the end of the run, if there's some variability, that means there's an issue on the instrument, and that's where we remove that part of the sample. So it's not cell type specific. The only automated QC function on FlowJo 11 is the signal stability check. Is that correct? No, so you have the flow rate, signal stability, and dynamic range. So you have 3 check there. If flow rate fluctuates but signal is stable, can I still take all the event? Yes, Gita, that's personal preference, or other algorithm, for example, Peacock's not taking in consideration the flow rate. So if you, when you look at the QC, if you think that the flow rate has nothing to do with an issue on your sample, it was not a technical issue, it was just, as I mentioned, a change in the speed by the user, you can remove the flow rate in your QC. You're welcome, George. All right, let's wait a couple more minutes if there's any more question. While doing that, I'm just gonna give you do the promotion of the next webinar. It's gonna be on BD Research Cloud. In BD Research Cloud, we just released automated panel creation feature. So now you just need to put the marker or the cell population that you want. So you don't even have to put the marker. You can just say, I want memory T cells, for example, and based on the instrument that you want to run or detect those cells, we're gonna give you the best panel to run. So a really nice feature. So Emily is gonna talk more about it on January 23rd. So I highly encourage you to register to that webinar. Um, I did a group, ran the QC, and got my bad and good event gate. Then I added another group, we ran QC, and it only showed me my bad event. The sensitive auto to put the sample. So no, so when you run the QC, the good and bad event is on every group. You see that's applied to my experimental data. So it doesn't matter if you create additional group. I can create a group samples and go for to have any keyword there. Maybe I can just put team name, contain COVID, add team name, contain flu, okay, add create group, should have a group sample, missed it, did this mistake there, that's fine, click and drag. Okay. So I can create my group if I go in my group sample because my gate is on all the experimental data. I can still see my good event and bad event. So still gonna be white, telling it that's applied to all the sample. The QC is not applied to your composition. That's the only thing that's not applied. So we don't run QC on composition active, only on experimental data. Yes, webinars recorded, copy of slide, PDF or other. No, we cannot share the slides, but you will have the slide on the recording. Yes, it works on any instrument. It's not limited to BD because you have this information in the FCS file. We have the time gate, often the time in every FCS file, that's standard. So you can run it on Sony, on a Cytec instrument, on Beckman instrument or whatever. The QC works on every instrument. If you do post-acquisition composition in FlowJo, do you recommend doing that after the QC? Not familiar. How does it done in v11? Um, when we design the software, we on your navigation bar there, we basically create the order of your analysis. So it's basically your metadata manager, so where you can look for your keyword, add keyword, adjust your parameter, create parameter set. Then is your QC, then is your composition, and after you go for your gate. So that's the order we decided to do in FlowJo 11. Doesn't mean that you cannot do the other way around. You can do your composition first and do the QC after. But when we designed the software, that's what we had in mind to go from put my sample into FlowJo, annotate it if needed, then go directly to QC before you do anything. But as I said, the QC is not apply on your composition control, so it doesn't really matter if you do your composition before or after in the QC. Yes, George, the FlowJo 11 workspace are compatible with FlowJo 10 workspace. So it's FlowJo a workbench in v11, a workspace in v10. So you can, when you do your analysis in FlowJo 11, you can save it as a FlowJo 10 workspace. So for example, if you hit a word block, one of the functionality that you use in v10 is still it's not currently available in FlowJo 11. You can save your analysis in FlowJo 11 as a v10 workspace, so you can go back in v10 to finish your analysis. Or if you already did your analysis in v10 and now you want to do the QC in v11, or you want to use the table and the chart in v11, you can import your FlowJo 10 workspace in FlowJo 11, and we will be able to read everything, even if you run plugins in FlowJo 10, we're gonna be able to import the result of this plugin in FlowJo 11. And Justin, for compensation, I'm not gonna go too much in detail. If you want to know more about compensation, there's a webinar on compensation in FlowJo 11, or you can go on our website, documentation. Where is that? Did I close the window or did I left it? Oh, there you go. It's there. If you go on flowjo.com, you go in Learn tab, you have help documentation for FlowJo 11, and you can go in composition and mixing. And here you're gonna have all the explanation on how to calculate your unmixing composition in FlowJo. And if you go in the webinar, we have one composition and mixing in FlowJo 11 that's coming in February. I thought it was done already. Oh no, we did one in November. That's what I thought. And another one in February. Thank you. Have a good one.